So in today's video, we are going to talk about pull versus push ingestion, okay? And we'll try to go through and understand everything around it step by step. So we'll try to understand what does push ingestion means and what does pull ingestion means. And then we'll also, of course, try to understand where each one of this is used in real world data engineering systems, and we'll try to understand the relationship between streaming versus push ingestion and batch versus pull ingestion, and then we'll of course try to understand the trade-offs between them before you pick either one of these for designing your data pipelines, and then we'll conclude the today's video. Okay, and to be honest, actually I think this is one of the topics like where a lot of beginners, or where just not just beginners, where like a lot of engineers assume that the decision does not like matter, because at the surface it's just how data gets into the system, right? Because it's just like ingestion, people think. But like once you work in any production systems, especially with APIs or relational databases or IoT devices or like CDC workloads, you kind of realize that this decision can completely like make or break your data pipeline or even your data platform, for that say. Okay, it also completely it also completely changes like how reliable your data platform is. So let's try to take it slow, and let's kind of try to understand each and everything in detail. Okay, so but starting with, we'll try to understand what does like push and pull ingestion actually means. Okay, let's start from here and then go step by step. Okay, so what does actually push ingestion means, and what does actually pull ingestion means? Okay, so pull ingestion means it's like the data pipeline goes to the source system and then fetches the data. Okay, and push ingestion means source system sends the data automatically to your data platform. Okay, so in pull ingestion, what will happen? Data pipeline goes and fetches the data from your source. Okay, in pull ingestion, basically your data pipeline goes and fetches the data from source. Okay, and then in push ingestion, what happens is basically source system sends the data automatically to your data platform. Here source system sends the data, and in pull ingestion we will go, means our data pipeline will go and fetch the data from source. Okay, and so again, if you have to simplify it more, so in push ingestion, basically source is the one who is initiating the communication, right? And then in pull ingestion, okay, in pull ingestion, ingestion system, our data pipeline or our data platform initiates the communication with source. Data pipeline or data platform or or ingestion system, so initiates the communication, okay, with source. So at this point, so don't worry, like if you don't know when to pick each other while designing the data pipelines, we are of course going to discuss that into the that further into the video. So now I'm just explaining what does pull ingestion actually means, and push ingestion actually means, and of course we will talk about when to use each one of them in detail. Okay, so now what we will do is, now let's try to apply this to the real world data systems. Okay, so maybe let's start with pull ingestion. Okay, let's start with pull ingestion. So pull ingestion is actually extremely common in ETL systems. Okay, I'm saying pull ingestion is common in ETL systems, and if you don't know what does ETL means, it means like E for extract, and T for transform, and L for load. Okay, so essentially what we are saying is, so pull ingestion is, we are saying pull ingestion is extremely common in ETL systems, and E for extract and T for transform and L for load. Okay, and extract means getting the data from source, transform means cleaning or reshaping it by applying our business logic or by enriching it with other data systems or other source data, or maybe also enriching it with the manual inputs. Okay, with some kind of reference data, or maybe deduplicating it, or standardizing the formats and all that stuff. Okay, and the load finally means storing it into some warehouse or lakehouse or any kind of storage. Okay, and yeah, and when you basically run a query on source database like every hour or every day or every half a day to fetch new or updated data, okay, that's basically the pull pattern. Okay, for example, let's say we have sales table in PostgreSQL. Okay, and let's say we are ingesting data hourly. For that, how normally SQL query would look like is, let's say, so you'll normally write something like, if you have sales table, select star from sales table where updated timestamp, okay, is greater than last extraction timestamp. So what I'm saying is, when you normally run a query on source database like every hour or every day to fetch new or updated data, so that's basically the ETL pattern. That's basically the pull pattern we are talking about here. For example, let's say if we have a sales table in PostgreSQL or any kind of relational database, and let's say we are ingesting the data hourly, so that query might look like this: select star from sales table where updated timestamp is greater than last extraction timestamp. So this query is basically your data pipeline, which is saying like, give me only the records that have changed since the last extraction. Okay, so what we are saying is, give me only the records that have changed since the last extraction time. Okay, and normally pull is actually extremely useful when the data does not need to be real time, and when business decisions like happen like periodically, like maybe daily or weekly or monthly, and when touching the source system too often may slow down the source system, then pull pattern is like extremely useful. Okay, so maybe let's try to write down and take it step by step. Okay, what I'm saying is, pull ingestion is extremely useful when the data does not need to be real time. Okay, and also pull ingestion is useful when business decision happen periodically instead of immediately. Okay, business decisions happen periodically, okay, instead of instantly. And when we say periodically, it's like daily or monthly or weekly. Okay, and then pull ingestion is also like extremely useful when touching the source system directly too often may slow it down. Okay, touching too often, okay, if touching the source system too often is slowing the source system down, then we'll kind of schedule the pull ingestion job to maybe run like every once in a while, so that it won't put a lot of burden on the source system. So what we'll normally do is, like, we'll try to fetch the data from source system not in business hours, or not when there is like a lot of load from the customers. Okay, so then we'll try to limit touching the source system too often. Okay, so that's when like pull ingestion is like normally you can see is really useful. And for these like typical like real world use cases like include like monthly payroll and BI dashboards, or yearly audit and compliance exports, or or also reporting from SaaS tools like Salesforce or SAP, BW, or Workday as well. So because like pull ingestion gives predictability and control over the load. Okay, let's maybe also try to talk a little bit more about the real world use cases. So what I'm going to do is I'm going to probably list down use cases here, and then I'll probably list down why the pull works for these use cases. Okay, so let's talk about some use cases. So maybe first use case would be payroll, right? And payroll normally happens only monthly once in most cases. Okay, I'm not talking about like edge cases and all. I'm talking only about like normal general cases, which is payroll happens monthly. So here why pull works is because here nobody needs the second by second updates for payroll, right? Here nobody needs second by second updates, right? And in case of also some BI dashboards, okay, so here also pull might work fine because most often you will be updating like BI dashboards like every 15-60 minutes, or maybe once a day or once a week as well, right? So here pull should be fine, because here 15-60 minute delay or once a day or weekly is also acceptable. Okay, and even if we talk about like yearly audits are like compliance exports. So here also basically pull or we are saying like batch pull, in brackets I will write ETL/batch, should be fine, because for this case it's just like simpler and predictable. Okay, and then even if you talk about like reporting from SaaS tools like Salesforce or SAP, BW, or Workday, in most instances they normally expose like scheduled API queries, and you'll normally pull the data from those ones. Okay, so for them also like pull should be fine. So so the thing with the pull is pull ingestion like normally gives you predictability and control over the load. Okay, so and pull is, again I'm repeating, pull is like normally useful when data does not needs to be like real time, and when business decisions happen like periodically, for example like in daily or weekly or monthly manner, and then pull is useful. And also it is useful, let's say for example if you are trying to touch or connect to the source system too often, and whenever you see like connecting to the source system is slowing down the source system, then also pull is happen, because you can schedule the pull ingestion to happen during not so busy hours, or basically work hours, so that it won't put load on the source system, and it won't your pull queries won't go into contention with the queries that the users are performing from uh, business side or operation side in work hours. Okay, so that's when pull is useful. Okay, so now if we talk about push ingestion, now moving on to push ingestion. Okay, now moving on to push ingestion. So push ingestion is when source itself like triggers the data transfer. Okay, so what we are saying is here source is the one who is initiating the communication with the platform, okay, or your data platform. So in push ingestion, normally source itself triggers the data transfer. So we should always remember it. Okay. So in push ingestion, source is triggering the data transfer. In pull ingestion, data platform is initiating the communication with the source system to fetch the data. Okay. So and for push ingestion, a great, like for example, real world example would be like CDC. So if you are wondering what is CDC, CDC is basically change data capture. So don't worry if you don't know so much about CDC. Okay, in simple words, it's like it's a way of capturing the changes that are happening in the source system. Okay, so as soon as some kind of insert happens or write happens or update happens or deletion happens in the source system, so we should be able to capture those changes as part of our downstream processes, right? And CDC is basically one of the technique. Okay. Or one of the pattern in order to capture all those changes incrementally. And yeah, and CDC means the system records only the changes. Okay, instead of rereading the entire table, system basically records only the changes and then sends you only those changes. Okay, and normally many modern systems nowadays like they support CDC first of all, and then they push changes through normally triggers and binary logs. So what we are saying is many modern systems, so they normally push changes through triggers and binary logs, something called as binary logs. Okay, and triggers is basically like for example, triggers will be created in the database, and normally what happens is database runs some custom code whenever a row changes. Okay, whenever a row in the table changes, then the database runs the custom code and do some other thing. Okay, and then in case of binary logs, okay, what normally happens is database kind of logs every write operation. Okay, for example, common examples for this would be in case of MySQL, you will have something called as bin log. Okay, if you have ever worked with CDC or anything, or also in Postgres you have write ahead logs, right? Okay, something called as WAL. Okay, so and normally what happens in binary log CDC is like whenever any insert or update or delete happens, all that every insert or update or delete gets written to some log which is called binary log. Okay, and the ingestion system, normally our ingestion system or our data pipelines consumes the log in real time. Okay, so if you want to see, for example, how this kind of log looks, let's maybe write one example event of how it looks. Okay, so for this one example event would be, let's say some update is kind of happening on your transaction table, then in binary log you would be able to see something like this. Okay, so this will be some JSON, and then there will be some key like table, and then you will see the table name as value. Okay, and then you will also see, for example, what kind of operation is happening on the table, like whether it is update or delete or insert, like any kind of operation, whatever the operation happening on the table, right? You will be able to see that. Okay, and then you will also maybe see like before and after status. Okay, so something like maybe here status is something like pending. Okay, and maybe after you will be able to see status as completed or something like that. Okay, so and of course you will also see some kind of timestamp of when all this event happened, right? So this is what normally you will get to see in binary logs. Okay, and this is a push, and basically push is kind of right choice when latency matters and when business logic or when business needs to make decisions immediately, or when business logic reacts to events instantly, and when operational systems like cannot be queried heavily during like work hours or any kind of hours, then push is basically the right choice. Okay. So what we are saying is push is right choice when latency matters. So when latency matters, push is kind of the right choice. For example, in kind of streaming applications, or in case of fraud detection, then push is basically the right choice. And also whenever like business logic needs to react to events instantly, or business needs to take some kind of decisions like instantly, then also push is the right choice. Business logic needs to react to events instantly. Okay, then push is the right choice. And also in case like for example some operational systems cannot be queried heavily. Okay, so querying is fine, but should not be cannot be queried heavily. Okay, heavily is the keyword here. Okay, then also push is the right choice. Okay, and also actually one more like super example for this would be like, let's say IoT telemetry. Okay, let's say imagine there is one kind of a factory with maybe some kind of 10,000 or maybe some 50,000 or 20,000 sensors in that factory. And then what that sensors will be doing is, so they will be reading some kind of temperature readings each and every second, and then all that sensors will be sending that temperature readings to somewhere. Okay, so imagine if you have kind of like 10,000 sensors or 20,000 or 50,000 sensors. So if you want to read the temperature readings, whatever that sensors are recording, now in your data pipeline for this pull pattern would be extremely difficult, right? How would you actually connect to all that 10,000 or 20,000 different sensors and pull the data? Okay, the connection itself like is it's so much difficult, right? So what will happen is normally in case of real world, what will happen is all that sensors, instead of you trying to connect to that sensors and pull the data, what that sensors will do is that sensors will kind of push the data to the message queue. Okay, and message queue is the only place where you have to connect from your data pipeline and pull the data, or they will be sending the data where you have to kind of listen to the message queue and consume the data. Okay, I hope it makes sense. Okay, and that's about push. Okay, and normally in case of like this sensors like IoT telemetry, like it would be like really impossible and inefficient to like query every sensor continuously, right? So that's why instead each device pushes its reading to a message broker like Kafka or Azure Event Hub or MQTT, and then from there you will be listening to these event hubs or Kafka streams, and then or MQTT, and then you will consume the events from there. Okay, and this is called push ingestion. Okay, so even though it is push, you still kind of need to consume it, but here you are not hitting or you are not communicating with the source system directly and then fetching the data. You are here kind of communicating with the broker. Okay, you are here connecting to the message broker. So that's where that's what you need to understand. That is the difference. Okay, so this is the subtle difference you always need to keep in mind. Okay, because even though push also kind of feel like you might question yourself, oh, but you were saying like in push ingestion, source system only push the data, right? Of course it will push the data, but not most of the time. In case of streaming, it might not be directly to your tables. Okay, you still need to connect to that message brokers like Kafka, Azure Event Hub or MQTT, and then from there you need to fetch and process the data and then load it into your tables or wherever. Okay, so but that is called push ingestion. So here source is the one who is initiating the communication. Here for example in IoT telemetry, sensors are the one who are sending that temperature readings to broker, and from there you are pulling the data or like listening and then fetching that data. Okay, By now, I think you might have kind of understood pull. Okay, whenever we are talking like pull, we are kind of indicating that it's kind of like batch or ETL. Okay, and then whenever we are talking about like push ingestion, it is kind of going well with streaming ingestion, right? So if you don't know what does like batch ingestion and streaming ingestion means, like I have made a video about what does batch and streaming ingestion means. Please go through the playlist and check the video. It would be like really nice for you to know that as well. Okay. Now let's try to understand the correlation between streaming versus push and why they are connected. Okay. Let's try to understand streaming versus push and why they are connected, or how they are connected basically. Okay, so most of the time streaming ingestion almost is always uses a push pattern because the data never waits, right? For example, let's say there is maybe like electric car, or there is like maybe Tesla car. Okay, so what Tesla car will be doing is it will be kind of continuously pushing the speed details or battery and temperature and the GPS data, right? So this is kind of streaming, and then vehicle is kind of pushing the data. Okay, you can see, right, already you can feel that they are connected, streaming versus push. Mostly in case of streaming, source itself will be pushing the data. Okay, and then also in case of like let's say trading system. Okay, trading system in the sense, if you have ever used like trading view, or if you are in India maybe like Grow or Zerodha or Upstocks, then you might have observed what will happen is like there will be a trading system. It will kind of like stream all the price updates. Okay, price updates are all the candlesticks, low and high prices, or how the candlestick moves and how price pattern forms. All the pricing data it will be pushing to the user interface like multiple times per second, right? So this is streaming and it is pushing the data. Okay, and also in case of food delivery apps. Okay, delivery app also like streams driver location and ETA events as well, right? So here basically you can, if you see, maybe let's write down these examples. So one thing is we talked about like Tesla cars. Okay, pushing the speed and temperature readings and GPS data, and then trading systems like Upstocks or Zerodha, and Grow, or trading view, or all that systems will be pushing multiple price updates per second. And also in case of like food delivery app like Zomato or Swiggy. Okay, they will also be kind of sending or streaming the driver location and ETA events, like where is the driver now, how much time will the order takes for you to reach your location. All that kind of ETA events they will be pushing as well. Okay, so because here basically there is no polling or pulling or querying, right? Because here waiting itself breaks the product experience. We have also discussed the same in a previous video, which is batch versus streaming ingestion. So again I'm going to repeat. So let's say, okay, you have ordered a food from delivery app, which is like Zomato or Swiggy, and then imagine that that delivery app is updating the driver location or where your order is now, all the details, let's say only once in a day. Then it's like doesn't make sense at all, right? So because as a user, you always want to know how much time it takes for the order to reach your location, because you will be hungry and you will be waiting for the food, right? That's why you want to know. So that's why here streaming or pushing is actually built into the product experience. Okay, so while push versus pull and batch versus streaming are different discussions in real systems, but most often, I would say, most often pull is normally corresponds to batch. Okay, most often, not like always, but most often pull always corresponds to batch, and push always or often corresponds to streaming. Okay, so you have to keep this in mind. This is probably the most important thing, okay, that you have to keep in mind, okay. And and of course this is not always, and it of course varies from projects to projects and implementations to implementations, and how your data platform is built around, and how does your company structure looks like, and how does the source system model looks like, whether it also depends on whether your company owns the source systems or not, because most often if your company doesn't own the source systems, then what also might happen is the source systems might not want to give away all the, for example, all the access to you, for example, for you to fetch the data. So that's why, even though it might still be once a day, sometimes they might also prefer to push the data, even though if it is just once a day, okay. I'm not talking about like all that rare edge cases, but most often pull is corresponding to batch and push is corresponding to streaming, okay. Not always, but most of the time, okay. and now if we have to talk about kind of like trade-offs, okay, let's maybe talk about trade-offs now. So maybe let's try to summarize, okay, and talk about the trade-offs. So pull ingestion, okay, so we are talking about pull and push, right? So pull ingestion often gives you simplicity, okay, it gives you simplicity, and it is basically easy to schedule and easy to retry and easy to manage, but it can increase the load on your source database if you query it like too often or fetch large data sets repeatedly, right? Okay, but what we are saying is, simplicity wise it's simple, okay, and easy to schedule, okay, easy to retry, okay, because even if your data fails, your data pipeline fails, the data will still be available in the source system, so you can always retry and just rerun the job, and then it will still be able to fetch it, okay. and of course it is easy to manage relatively, huh? but remember guys, it can increase load on the source, it can increase load on the source system. So it can increase load on the source database if you query it like too often or fetch or try to fetch large data sets repeatedly, okay. And in case of push ingestion, okay, push ingestion main advantage is it always gives you low latency, okay, low latency updates to the data, okay. As soon as some kind of change happens in the source system, in matter of a few seconds or minutes, most often you will get the updates to your data platform as well, okay. So push ingestion gives you low latency and of course event driven behavior. So it gives you low latency and event driven behavior, but yeah, they will sound super nice, okay, like low latency and event driven behavior, they are nice, they are quite nice, but if your business don't need it, or if you're not getting like any business benefit from low latency and event driven behavior, then basically you should not do it, because it requires more engineering effort, more monitoring, and often more infrastructure like Kafka or Kinesis or PubSub or MQTT, and it also kind of requires for you to have your compute on like 24/7, okay. So always you need to keep that in mind. So one con is basically more engineering effort. Yeah, so more engineering effort, I'm not saying it's bad, it is like completely fine, okay, as long as you have some kind of business benefit, okay. And if you talk about like more trade-offs, pull systems often fail gracefully, and even if they fail, again I'm saying like you can rerun the job and then they will be able to fetch the data, because data is always there in your source system, right, hopefully, okay. And sometimes it might not be there as well, but I'm again not talking about like all that extreme cases like where the data in your source system might be getting overwritten, okay, or deleting and loading or whatever. I'm not talking about all that extreme cases, but most often since you will be trying to fetch the data from operational databases, which are your source system, so most often they will maintain history and everything, or some part of the history at least. Okay. And yeah, that's why pull systems like fail gracefully. Okay. And then in case of a push systems, so they kind of require more recovery logic, like logic like checkpointing and offsets and replay topics and all that stuff. Okay. So they require checkpointing or offsets or replay topics and all that stuff, or idempotency. Okay. And all that stuff. Okay. And one more important detail is, with push the source system controls when the data moves, and with pull you control the schedule, right? So again, here in pull you control the schedule, and in case of push, source controls when data moves. Yeah. So yeah. So again, the main advantage of pull is basically, yeah, you can always connect to source and then fetch the data and then whatever. But then in case of push, it's mainly like low latency and event driven behavior. Okay. So please remember that. So, and these differences like matters a lot, especially when debugging failures across teams. Okay. So you need to know all these push and pull patterns. Okay. And normally, if I have to decide, like personally, okay, then if I would be like, if a delay does not harm business outcomes, then I'll go with pull. If the business reacts to events instantly, then I'll go with push. Okay. Or maybe even simpler, choose push when the business cares about now, and choose pull when the business cares about like correct plus consistent data and all that stuff. I'm not saying like you won't get like correctness plus consistency in push, but you will also get that. But it's mainly more about processing the events in real time, and especially when your business outcomes depend on the real time data, or when your business needs to take some kind of decisions instantly, or you know, when it is part of product experience or user experience, then you need to go with push. Or when the business only cares about correctness and consistency, or when you have to have control over the source. Okay. Not control over the source, not in that way, but if you have to control the schedule of when you have to fetch the data, and if you want to just have a simple, if you can get away with simple simple pipelines for, like, maybe if you are just building some BI dashboard which just needs to update like a daily once or weekly once, then pull might be fine. Okay. But again, we need to remember, guys, it's not very often you will get access to the source system directly. Okay. Sometimes due to access control and access policies and everything, sometimes source systems might not even give you like access to the direct access. So they might give you, in some cases they will give you access to read replicas and all that stuff, but in some cases not even that. Okay. They will say, we don't, due to some access restrictions or due to some governance, we don't like to give access to the access to you to pull the data. Instead they will say like, we would prefer to push the data. So in that sense, in that case, okay, even though it won't be streaming, but you still need to accept it, and then they might be able to like push the batch once in a day. Okay. So it's just, it will still be batch even though they are pushing. Okay. It's not like push corresponds to streaming and pull corresponds to batch. Okay. There are also of course some exceptions and all that stuff. Okay. So so in order to to conclude, basically that's pull versus push ingestion. I hope like kind of explained in a little bit practical way. And if you want a follow-up video where we break down CDC patterns or real-time ingestion architecture in maybe Azure or Fabric or Databricks or Snowflake, please give me a comment, and I'll of course try to do that. And I hope you have learned something from this video. And if you do have learned something, then please like the video and share it with your colleagues or friends, or your fellow data engineers or data guys. And yeah, and if you like this content, please like the video and share and subscribe to the channel. And actually comment down. I'm really curious to hear from you whether you are using push versus pull pattern, which of them you are using, or or mix of both in case of different source systems. Okay, so yeah, and I hope you like the video again, and I'll come back to you with one more interesting topic. And until then, stay tuned and see you, and good morning or good night wherever you are watching from, and talk to you again. Bye.